Hello everybody. So today's lesson is going to be an interesting one. We're going to look at, once again, using our four main operations: adding, subtracting, multiplying, dividing. And we're going to look at doing it with fractions. So this is all about operations on fractions, okay? So we're going to start with multiplying and dividing, because those are actually the easy ones with fractions. Alright, so let me show you. Well, just some tips first. For multiplying, it's super easy. You just multiply the tops, and that gives you the top part. You multiply the bottoms, that gives you the bottom part. And then you need to be sure to reduce the fraction if it reduces. Okay? Now, these steps are not super important because you could reduce some things first and multiply, or reduce as you go. It doesn't really matter. But let's jump into some examples to kind of see some of this. So, for instance, if I'm doing negative 2/5 times negative 4/3. Multiplying fractions is really easy because you just multiply the tops and you multiply the bottoms. So what is 2 times 4? That's 8. Piece of cake. What is 5 times 3? That's 15. Once again, really easy. What's a negative times a negative? A positive. And so here we are, positive 8 over 5. Does this reduce any? No, there's no number that divides evenly into the top and the bottom, so we're finished. Okay? That's way easier than trying to multiply decimals. Fractions are where it's at, guys. Fractions are awesome. That was pretty easy, right? Let's do more examples. About 3 over 8 times 7 over 9. Okay? So I can multiply straight across, then reduce. Some people try to reduce things from the tops and the bottoms before they get started. Let me show you. I didn't show an intermediate step in here, but all you're doing when it comes to multiplying fractions is you're multiplying the tops to make the top, and you're multiplying the bottoms to make the bottoms. So some people see that the 3 and the 9 would reduce down. Some people don't see that, and so they go ahead and carry on through, and they see 3 times 7 is 21, and then they go on to do 8 times 9, and they get that that's 72. Then those are large numbers. It's hard to see if they reduce or not. I'm going to tell you they do reduce. Both of them are divisible by 3. And the top one, 21 divided by 3 is 7. And 72 divided by 3, I believe, is 24. So sometimes reducing these at the end can be kind of tricky. So let me show you what it's like to reduce in the middle. So like I said, you may want to reduce before you multiply together. So 3 over 8 times 7 over 9. And I'm going to take the annoying step of smushing them together like this. And you're going to say, wait a second. Before I begin, am I allowed to reduce down the 3 and the 9? And the answer is yes. Yes, I can reduce down the 3 and the 9. What number divides evenly into a 3 and a 9? Oh, that would be 3. I could divide both of these by 3. Well, 3 over 3 divides to 1. So up top I have a 1 times a 7. And on the bottom, 9 over 3 divides down to 3. So I have 8 times 3 on the bottom. So that's a lot simpler of numbers. 1 times 7 is 7. 8 times 3 is 24. A lot simpler of a way of getting the same answer. So sometimes it helps to reduce before you start multiplying. Okay? So one more example of that. Let's say that we do 4 over 5 times 15 over 16. If you multiply these are going to be large numbers. But it might be simpler to take the time and see if you can reduce any of these before you actually do multiplication. And the answer is yes, some of these reduce. Look at this. The 4 and the 6 are both divisible by 4. So they're going to reduce down. 4 divided by 4 is 1. 16 divided by 4 is 4. And that's not it. The 15 and the 5 are both divisible by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. So what do we have up top? We have 1 and 3. 1 times 3. What do we have on the bottom? 1 times 4. Oh my, that's really easy. 1 times 3 is 3. 1 times 4 is 4. 3/4. So if you did not simplify at first, what would we have gotten if I would have just multiplied straight across? These are going to be large numbers. This is going to be 60 up top. And on the bottom, let's see, I believe that is 90. I'm trying to do it in my head. 50 plus 30, yeah, 90. And you would have had to work your way down to realize, did I do that right? 5 times 6. 4 times 15. You would have had to work your way down to figure out that that is 3 over 4. That's not right. One of these I did wrong. 4 times 15 is what? Right, why don't we open up a calculator and do this so that I'm not doing things in my head. It's, I see what it is. It's 5 times 16. 5 times 16 is 80. Not 90. There we go. We fixed that. Whoops. And then you would have to work hard to reduce that down. I don't know how many steps it would take you, but to get it down to 3/4. Okay. Alright. So sometimes it's way easier to reduce before you dive in too deeply. What about dividing? Because I said we're going to do dividing and multiplying. We just did multiplying. This is where you have to remember what I told you last lesson. Dividing is just multiplying by the reciprocal. Okay? Multiplying by the reciprocal. Remember, we know what a reciprocal is. We did that in the first lesson. So we're applying all this knowledge together to be able to answer some of these questions. So I don't really need to practice dividing that much. So look at this. 3/5 divided by -7/10. And here's what we're going to do. We're going to say, wait a second. Dividing is the same thing as multiplying, so change it to a multiplication, by the reciprocal. What's the reciprocal of 7 over 10? Reciprocal of 7 over 10 is 10 over 7. So that's actually, now we already know how to do a multiplication problem. So we just turned it into something that we knew how to do. First off, what's a positive times a negative? That's going to be an ugly baby, a negative. Up top we have 3 times 10. On the bottom we have 5 times 7. Does anything reduce or divide out? Yeah. 5 divided by 5 and 5 divided by 10. Those are both divisible by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. And so there we go. Up top we have 3 times 2, 6. On the bottom we have 1 times 7, 7. Okay? So I can turn any division of fractions into a multiplication of fractions. And it makes life way easier. Let's do a few more examples to make sure we feel cozy with this. So for instance, 2/7 divided by 6 over 5. Okay. Well, what I'm allowed to do is take the 2/7 and say, oh, dividing is just multiplying by the reciprocal. What's the reciprocal of 6 over 5? 5 over 6. If you don't understand or remember what a reciprocal is, go back and look at lesson 1. Okay? And so then let's see, 2 times 5 up top, 7 times 6 on the bottom. And you could try to reduce now, or you could reduce at the end. I'll wait till the end because it really doesn't matter when you do this. This would be 10 over 42, and this actually reduces by 2. 2 goes evenly into either of those. So I'll get 5 over 21. So you could have reduced before you multiplied or after you multiplied. So look, I told you one of my goals throughout this class is to get you to be less afraid of fractions. And so far, multiplying and dividing fractions is really just the same thing. Multiplying fractions is actually pretty easy. Try that with decimals. It's not easy. All right, let's do some more dividing. I'm going to get some new paper here. How about this one? 3/5 divided by 12. And what's going to happen is some of y'all will panic because this does not look like exactly what we've had. Because what we have had is a fraction divided by a fraction. And when we throw a whole number into it, you're like, oh no, this is it. It's the end. This is different. But wait, stop and think. I know how to make this a fraction. Remember the first day of class, the first lesson in class, we said we could turn anything we need to into a fraction by putting a 1 underneath it. So now I have 3 over 5 divided by 12 over 1. I can turn this division, 3 over 5 divided, I could turn it into multiplied by the reciprocal. 12 over 1, that's going to become 1 over 12. And then I could reduce now or reduce later, it doesn't matter. Get 3 times 1 over 5 times 12. This one is going to reduce because the 3 and the 12 reduce. So see, I'll reduce at the end just because it's less about writing. So 3 will divide evenly into both of those. 3 is 3 times 1. 60 is 3 times 20. And so the 3's can be gone, and I have 1 over 20. Alright? So I can divide a fraction by a whole number, or a whole number by a fraction, by remembering to just turn it into a fraction. Okay? Alright, so now, adding and multiplying with fractions is the easiest part. The more difficult part about fractions is adding and subtracting. Those are the harder parts when it comes to fractions, adding and subtracting. So to be able to add or subtract fractions, you need something. Okay? What do we need? We need them to have the same bottoms of the fractions. A fancy word for the bottom of the fractions, denominator. We need them to have the same denominator to add or subtract the tops of the fractions. The fancy word for that is numerator. Okay, so let me show you some examples. So to add and subtract fractions, let's just start really simple. Let's start with ones that already have the same denominator. So 5 over 7 plus 3 over 7. And I actually don't have to teach subtraction because that's the same thing as adding, but I could do this either way. They have the same denominators. So when you are adding or subtracting fractions, you make sure they have the same denominators and you leave that denominator alone. The bottom of this fraction is 7. What's happening up top is the operation. So if I'm adding 5 sevenths plus 3 sevenths, that's going to be 5 plus 3 over 7. And what is 5 plus 3? 8. 8 sevenths. Does this reduce? Nah, so we're finished. Could I do a subtraction? Yeah, it's the exact same rule. If I wanted to do a subtraction instead, it's no big deal. It's just subtracting instead of adding. And you could say that's 5 plus negative 3, but we all know 5 minus 3 is just 2. So you get 2 sevenths. So if the denominator is already the same, there's no stress. It's really easy. Do you think every fraction that we ask you to add or subtract is going to have the same denominator? Sadly, no. So how do we fix this? So let's look at one that does not have the same denominator. So here's what we're going to try to do. We have a way of changing these. So the way that we're able to change these values is we are allowed to multiply by anything that our little heart desires, as long as we do it on the top and the bottom by that same number. Okay, so I can multiply 100 if I wanted to, as long as I multiply 100 on top and 100 on the bottom. I can multiply 7 if I wanted to, as long as I multiply it by the top and the bottom. So we want to choose intelligently, though. I don't want to keep just multiplying by random numbers, hoping to get them to be the same. What number could I multiply 4 and 5 by? What numbers to get them to reach the same numbers? There's always the lazy way of multiplying 4 by 5 and 5 by 4. That'd get them both to 20. But that's actually the first common multiple that we can reach, common denominator that we can reach. So here's what I'm going to do. I'm going to say, okay, I would like to make these bottoms the same. I can get them to both be 20. Whatever I multiply the bottom by, I need to multiply the top. So I need to multiply the top by 5 as well. Okay, so what's this first fraction going to be? 5 times 3. We already know how to do multiplication. 5 times 3 is 15. 5 times 4 is 20. Plus. I need to make this 5 the same denominator over here. What is it missing? It needs to be multiplied by 4. That would give me 20. Whatever I do on the bottom, I gotta do on the top. So I multiplied by 4 over here. I gotta multiply by 4 up top. 2 times 4 is 8. 5 times 4 is 20. So these are similar fractions. It's almost like we undid reducing. We did the opposite of reducing to try to make these have the same bottoms. So now that they have the same denominators, I can add or subtract whatever the operation shows the tops of the fractions. And it's going to stay over that 20. Notice I did not change the denominators. Now what is 15 plus 8? I believe that is 23. So then check, you got to check. Does this reduce? No, it doesn't. I'm finished. Okay. So that seems to take a little bit of effort. Let's do one more example of adding or subtracting fractions. So let's do 5 over 12 minus 3 over 4. And you look at it and you say, 12 and 4, are they the same? No. Can I multiply them to get them to be the same? Yes, there's lots of numbers. The most intelligent would be, I could just multiply 4 to get it to be 12 if I multiply by 3. And whatever I multiply on the bottom, I have to multiply by on the top. I don't need to multiply 12 by anything. It's already 12. If you wanted to think about it as multiplying by 1, you could, but that's not going to change anything. So what's the first fraction? 5 over 12 minus 3 times 3 is 9. 4 times 3 is 12. Right? Do they have the same denominators? Yes, that's exactly what we wanted. So now I can go in and put them into a single fraction with that same denominator on the bottom. 5 minus 9. And then we've done subtraction. You can go back and look in your notes or try to make sure you can handle this, but make sure you know how to do 5 minus 9. And that will give you negative 4 over 12. Alright? I asked the question here. I asked the question here. I'll ask it again. Can this reduce? And actually, yeah, this one reduces. We're not finished yet. What number divides evenly into both of these? 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So this is negative 1/3. On the test, if you were to leave it as 4 over 12, you would lose some credit, okay? For full credit, you need to reduce the fraction, okay? We had to reduce. Alright, so that is all we're doing today. It's adding, subtracting, multiplying, dividing fractions. Make sure you do your worksheet. Okay, make sure you take your time. Alright, and I hope y'all have a great day.